And the other thing I'd like to talk about, so far in this class, we've done so much with derivatives. And in terms of calculus, there's two big concepts in calculus. It's derivatives and integrals. So we've already talked a lot about derivatives. This last chapter, we're just doing a little bit of what is an integral. So something that I think could help is that an integral and a derivative are essentially inverse operations. So the better that you understand the derivatives, then the integral sort of comes directly from that. So I already talked about the word integral. Another thing that we call it is the antiderivative. So here we have some examples of, if you had a function like 7x and you took the derivative, that would get you to 7. Now we're going to take the antiderivative or integral, which I'll talk about in a little bit, and that's essentially getting from the 7 and working backwards and getting back to the 7x. So that's what we're doing in chapter 7. And if we just, maybe I'll just look at that bottom example here. So if you have x cubed, if you take the derivative, you get to 3x squared. Now in chapter 7, we're going to take the antiderivative of 3x squared, which means getting back to x cubed. Or you could think about it as, what would the original function have been where if I took the derivative, it was 3x squared. So here's some examples of finding the antiderivative. And I'm actually going to show the rules for this in just a second. But one, I think, really helpful thing in this chapter is to remember that since at this point we are more comfortable with derivatives, you can always check your work by taking the derivative. So for example, for 20, the antiderivative is 20x. To check your work, take the derivative. The derivative of 20x is 20. Okay, so that means that we've got the right answer here. And if I go down to number 2 here, the derivative of x to the 4th is 4x cubed, so that kind of verifies that I found the correct antiderivative. So use your knowledge of derivatives to help in this chapter. One extra thing that you're going to see here that we did not see when we took derivatives was this c. And what's happening is that when you take the derivative of something, like you take the derivative of just a number like 5, the derivative is 0. So that means when we take the antiderivative, it's like we don't know if there was just like a constant there that went to 0. And that's where this plus c comes in. So now when I switch from saying antiderivative to integral, the process is going to be the same, but you always need to add this plus c. And it's basically saying that there is more than one option of a function where the derivative, in this case what we're looking at, is 3x squared. So here, this is our new notation. So this little s type thing is the integral sign. Here's our part where we would normally have a function, 3x squared. The dx is really just saying that the variable that we're looking at is an x. And so we don't really do anything with the dx. It just sort of hangs out on the side there. So if we think about this, the antiderivative of 3x squared is x cubed, and that's because the derivative of x cubed is 3x squared. So that's how we check our work. But then we also have this plus c, because in theory, what function could we have where the derivative is 3x squared? Well, we could have had x cubed plus 5, or x cubed plus 10, or x cubed minus 7, or just x cubed. All of those derivatives would have been 3x squared. But when we take the integral, we always have the plus c, and that's indicating that there could have been some constant there to get that answer.